So this is part 3 of the test. In part 3 we had to fill out this grid, and I wanted you to read the material at the top first, which really all of the answers that you need are up here at the top, but you have to interpret the reading. So the atomic number is always equal to the number of protons. That's always. So let's see if we can apply that real quick. So first element we had was potassium. So if you go to your periodic table and look at potassium, it's sitting right here, and its atomic number is 19. So that tells you that this is 19. And since the atomic number is always equal to the number of protons, always is such a nice word because it's always true. That will be 19. Now it also says up here that if the atom is neutral, that means no charge, the electrons are equal to the protons. And then on this part of the test, it said assume that there is no charge for these elements. See right here, assume that there is no charge for these elements. So since there's no charge, then the electrons equal the protons. So that number is 19. All right, it also tells us that the protons plus the neutrons is equal to the mass number. Well, we don't know what the neutrons are, but we do know the mass number. The mass number is 39. It tells us right there. So that's 39. So now we know that the protons plus the neutrons is equal to 39. We know the protons were 19, so now 19 plus the neutrons equals 39. So the question becomes 19 plus something equals 39. Subtract 19 from both sides, and you find that the number of neutrons is equal to 20, because 39 minus 19 is 20. And of course the symbol for potassium was K, and K we see right here, K. Second question here, we have 80 electrons, but we were told that if the atom's neutral, the electrons equal the protons, and it says here that there is no charge, so these are all neutral atoms, so therefore if there's 80 electrons, there are 80 protons. We know that the number of neutrons is 122, so the mass number would be 80 plus 122, which would be 202. The actual element with 80 protons is mercury. It's right here. So that is going to be Hg. Atomic number is the number of protons, so that's 80. And then over here, the symbol will be mercury, hyphen. And then we put the mass number here, it's 202. I want you to notice that on the periodic table, the mass of mercury is 201. The only thing you can tell for sure by looking at the grid and the periodic table, the only thing the periodic table tells us for sure on this grid is the number of protons. All right, the next one is number 15. So if you go look at the periodic table, number 15 is over here. It is phosphorus. So that's P. The atomic number is 15, so the protons equal 15 because the atomic number is always equal to the number of protons. The number of electrons equal the protons if there is no charge. It says here that there's no charge for this chart, so therefore the electrons equals 15 as well. And then the mass is the protons plus the neutrons. So we know that the protons plus the neutrons is equal to 32. So this would be phosphorus. 32, and the number of neutrons would be 15 plus n equals 32, so n would have to equal 17. So that's the top part of that test. Now the bottom part, the protons and the neutrons work the same way. The electrons are a little different because it says that there are charges. So let's go back and see how to handle charge. If there's a positive charge, the atom has lost electrons, so the charge is positive. If there's a negative charge, the atoms gain electrons, so the charge is negative. So in this case, the charge is positive. Has it lost or has it gained electrons? Well, it's positive, so it's lost them, and it has 10. So it has 10 after it lost 3. Let me say that again. It lost 3, and now it has 10. It lost 3, and now it has 10. So how many did it have It lost 3. Now it has 10. How many electrons did it have before it lost the 3? After it lost the 3, it has 10. So before it lost the 3, it must have had 13. Now another reason you know that there's 13, and let me stop for just a minute. We know there's 13 protons for that reason, because it has 10 electrons after it lost 3. So before it lost 3, it would have had 13. And 13 electrons would be what it has when there's no charge, and so if there's no charge, the electrons equal the protons, and that's how you can tell there's 13. As in computers, on computers there's multiple ways to cut and paste and stuff. So there's multiple ways to get to these numbers as well. So another way to find 13 is it told you that it was aluminum. And so if you look at the periodic table, element number 13 right over here is aluminum. So that's another way you could have known it. And then of course once you know that the aluminum is 13, or that it's 13 and that it's aluminum, we also know the mass number is 28. Oops, it goes right here, 28. The atomic number is the same as the proton, so that's 13. And that just leaves us neutrons to figure out. So the protons plus the neutrons equals the mass. The mass is 28. Protons are 13. So the neutrons had to be 15 for the first row. Okay, second row, we've got a -2 charge. So that means we've gained 2 electrons. So before we gained 2, how many did we have? Well, I don't know. Well, first of all, we'd have 8 protons. So that means normally you'd have 8 electrons. But we've gained 2. So before we gained 2, we would have had 8. After we gained 2, 10. Because normally the protons equal the electrons. When there is no charge, the electrons equal the protons. So if there was no charge, there would be 8 electrons. But this -2 means it's gained 2, so you have to add 2 to its normal number, which makes it 10. Element number 8 on the periodic table is oxygen. You can see that right here. Oxygen's 8. So we'd put an O in for the symbol. For the hyphen notation, we'd write oxygen. And then we have to find the mass by adding the protons plus the neutrons. And 8 plus 16 is 24. And that particular isotope of oxygen really doesn't exist, but it gives you practice in figuring out what it is. So I put it on there even though it's fictitious. All right, the mass number, 24. We already just said that. And the atomic number for oxygen is the same as the number of protons, that's 8. Okay, for the next one, we've got atomic number of 50. Atomic number is always equal to protons, so that would be 50. Element number 50 on the periodic table, if we look at it, would be 10, Tin right here, 50. Okay, so we'd have Sn would be our symbol. The electrons would equal the protons if it was neutral, but since there's a +2 charge, it's lost 2. So it used to have 50 when it was equal to the protons, but if you lose 2, now you got 48. All right, the neutrons, you know that the protons plus the neutrons equals the mass. So 50 plus the neutrons equals 120. So the N has to equal 70. And then this notation is 10-120. So this 120 is the mass number, it goes right there. All right, last question on this section. We have an atomic number of 35. So atomic number tells you what the element is. And that's number 35, that's bromine. So that'd be Br. The mass number of bromine we have to get from adding the protons and the neutrons together, because you can't tell what the mass is off the periodic table, because this might be an abnormal isotope that I put on this document. So 35 and 40 makes 80. Remember, protons plus neutrons, so we have 35 plus 40, and that's 80. That's the mass number. So I might as well go ahead and put that in. Bromine dash 80. Protons, same as the atomic number, 35. The electrons equal the protons, so that'd be 35 normally, but this has a -1 charge. So -1 charge means gain 1. So from 35, we go to 36. All right, and that's the last part of the part 3 of the test. On a retake, it'll be the same format, but the questions will be different elements. So you need to be sure you know how to think through these, as opposed to just you can't just look up the answer exactly. You have to think a little bit.